Have you ever pondered about the significance of the number zero in your life? It's a question that might seem odd at first glance, but zero is more than just a placeholder or a symbol for nothing. It's a concept that revolutionized the world of mathematics and beyond. Our journey begins with the ancient civilizations of the Babylonians and Mayans. For the Babylonians, zero started as a space, a pause in their cuneiform number system. The Mayans, on the other hand, had a symbol for zero, a shell shape, and used it in their complex calendrical calculations. These cultures, separated by oceans and centuries, both stumbled upon the concept of zero independently. They perceived it and used it in ways that were unique to their societies and cultures. Our understanding of zero today is built on these early foundations. From these ancient civilizations, zero embarked on a journey of evolution and integration into the world of numbers. Did you know that the origins of the number zero trace back to ancient India? This is a fascinating chapter in the story of numbers. Indian mathematicians were instrumental in the evolution of zero, and it was their insights that first integrated zero into our numeral system. In the 5th century, the mathematician and astronomer Aryabhata used a dot to symbolize the absence of value, a precursor to our modern zero. This groundbreaking concept was further developed by Brahmagupta in the 7th century. He introduced rules for arithmetic involving zero, and even touched upon the idea of negative numbers. The concept of zero then traveled to the Arab world, along with the rest of the Indian numeral system, through trade routes. Here it was further refined and eventually made its way to Europe, forever changing the course of mathematics. The birth of zero in India marked a critical point in the history of mathematics. This unassuming symbol revolutionized numerical systems and laid the groundwork for countless mathematical breakthroughs. Can you imagine a world of mathematics without zero? It's almost impossible to conceive, isn't it? Zero, this seemingly simple concept, is the cornerstone that upholds the vast edifice of mathematics. It serves as the pivot around which the wheel of arithmetic spins, allowing us to perform operations like addition and subtraction with ease. In algebra, zero assumes an even more vital role. It's the magic number that transforms equations, providing balance and symmetry. When you multiply any number by zero, the result is always zero. It's the ultimate neutralizer. Moreover, zero also serves as a placeholder. Imagine trying to differentiate between 10 and 1 or 110 without the use of zero. It would be a mathematical nightmare. It's fair to say that zero is not just a number, it's a mathematical tool, a symbol of nothingness that paradoxically makes everything in mathematics possible. Indeed, zero is the unsung hero in the realm of mathematics. How does zero fare in different number systems? Well, let's dive into the fascinating world of binary and hexadecimal systems. In the binary system, zero plays a pivotal role. It's one half of the binary language, the other being one. Together, they form the basis of all digital communication, from the simplest of calculators to the most advanced supercomputers. Meanwhile, in the hexadecimal system, zero still holds its own. This system, used in computing and digital electronics, extends the binary system to 16 digits from 0 to 15, represented as 0 to 9 and A to F. Here, 0 is an integral part of the system, serving as the base value. So, whether we're talking about a system with 2 digits or 16, 0 is indispensable. It's the foundation, the starting point, the reference from which all other values spring. As we can see, zero holds its ground, regardless of the number system. What was the reception of zero in medieval Europe? Let's delve into this fascinating chapter of history. Zero's journey to Europe was not without its challenges. Initially shrouded in skepticism, the concept of zero was introduced through the works of the Persian scholar Al-Khwarizmi and the Indian mathematician Brahmagupta. However, it wasn't until the 12th century that zero began to gain traction in the European mathematical sphere, largely due to the translations of Arabic texts into Latin. Despite its slow start, zero was destined to play a pivotal role in the evolution of European mathematics. The concept of zero not only filled a void in the number system, but it also facilitated the development of new mathematical techniques. It was the keystone for algorithms and equations, enabling a more profound understanding of the universe's numerical fabric. The introduction of zero in Europe laid the groundwork for a mathematical revolution. How does zero influence the world of calculus? It's a question that unveils a fascinating journey into the realm of mathematics. Zero, this seemingly simple entity, plays a fundamental role in calculus, particularly in the concept of limits. Imagine a number getting infinitesimally close to zero but never quite reaching it. This is the essence of a limit, a cornerstone of calculus. It's through this concept that we can calculate the slope of a curve at a point, or the area under a curve, both of which are integral to calculus. Moreover, zero is instrumental in defining derivatives and integrals, two primary operations in calculus. The derivative measures how a function changes as its input changes, while the integral calculates the area under the curve of a function. Both rely heavily on the concept of approaching zero. Zero, in its subtle simplicity, is an unsung hero in the world of calculus. Without zero, the calculus we know today would not exist. Ever thought about the role of zero in the digital world? Zero is a paramount player in the realm of computer science, serving as the backbone of binary code. This simple digit, along with its counterpart 1, forms the binary language, the foundation upon which all digital technology is built. Imagine a world without zero. It would be a world without computers, smartphones, or even the internet. In binary code, 0 and 1 are used to represent all possible data states, making it possible to code any piece of information, be it a complex algorithm or a simple text message. The concept of zero also plays a vital role in memory allocation and data representation in computers. A zero can indicate the end of a string of data, or it can represent a null value, signifying the absence of any data. From the simplest programming languages to the most complex coding systems, zero is an indispensable part of the digital universe. In the digital world, zero is indeed a game changer. How has the symbol for zero evolved over time? This question leads us on a fascinating journey. The concept of zero, a cornerstone in mathematics, was not always represented by the familiar oval shape we know today. In ancient times, the Babylonians used two slanted wedges to denote the absence of a number. This evolved into a placeholder symbol in the Mayan numeral system, a shell-like glyph symbolizing the void. Centuries later, the Indians conceived a small dot to represent zero, a symbol that was later adopted and adapted by the Arab mathematicians. This dot gradually morphed into the hollow circle we recognize today during the Middle Ages in Europe. Through each transformation, the essence of zero remained the same, embodying the concept of nothingness. The symbol for zero has traveled through time and across cultures, each leaving its unique imprint on its form. It has evolved from wedges to shells, dots to circles, reflecting the progression of human understanding. The symbol for zero, though simple, carries a rich history. Have you ever contemplated the philosophical implications of zero? This simple yet profound concept embodying absolute nothingness has long intrigued philosophers. In many philosophical traditions, zero, or the concept of emptiness, is not just a numerical value. It's an idea that holds deep symbolic meanings and challenges our understanding of existence and reality itself. In the realm of Eastern philosophy, for instance, the concept of sunyata, or emptiness, is central to Buddhist thought. It suggests that all phenomena are void of inherent existence, pointing to zero as the ultimate reality. In Western philosophy too, the concept of zero has been a subject of debate. It has been interpreted as a symbol of potentiality, a state of pure possibility from which all things emerge and to which they return. Whether it's seen as a symbol of nothingness or a state of infinite potential, zero has always been much more than a numerical placeholder. In the philosophical realm, zero represents more than just a number. How does zero contribute to modern science and technology? In the realm of physics, zero is a pivotal point on the Kelvin scale, representing absolute zero, the lowest possible temperature where all thermal motion ceases. In engineering, zero is essential for measurements, calibrations, and setting baselines. It's also a key player in binary code, the language of our digital world. Zero's role extends even to space exploration. It's the reference point for spacecraft navigation systems, vital for successful missions to distant planets. In quantum mechanics, the concept of zero-point energy, the lowest possible energy that a quantum mechanical system can have, is a fascinating area of study. Moreover, zero is a cornerstone in statistical analysis, helping us understand patterns and trends in huge data sets, a critical aspect of modern technology. It's the starting point in algorithms that drive machine learning and artificial intelligence. Zero, the humble number, drives the wheels of modern science and technology.